Hi, my name is Don Bagwell from the IBM Advanced Technical Skills Organization, and this is the third in a series of video demonstrations on WebSphere Application Server for zOS. In this video, we're going to explore WLM classification and Granular RAS. In WebSphere for zOS, all requests that come to an application server first hit the control region, and one of the functions of the control region is to then turn and work with zOS WLM to classify the work based on rules that are found in the CB subsystem type. And when that is done, then WLM will pass back to the control region the service class and reporting class for the request, and that's what will be used to pass into the servant region. Now, one of the functions of WAS-zOS is to make this more granular by adding a classification file. And what the XML classification file does is it allows you to identify application requests using URI patterns or other request matching patterns. And with that, then assign a transaction classification name to the request. And that TC name will then be passed into WLM, and WLM can then use that to assign specific reporting class or service class to the request. We see many customers using this function to enable the running of multiple applications in the same application server, but having different WLM reporting classes for each of the applications. And what that allows them to do is to have greater visibility to the usage and performance statistics by application running in the same server with other applications. Let's take a quick tour of the operating environment we'll use for this demo. If we go under Servers, Server Types, Application Servers, we'll see the server Z9SR01A that we've used in the previous demos. If we go down to Applications, All Applications, we'll see that we have two applications deployed. One is the Super Snoop application that we've used before, and the other one is a JDBC application that does a simple select on a database table using JDBC Type 2 local connectors. And if we go down under Environment and Variables, we will see that we have a variable defined called WLM_classification_file, and that points to a classification file that will be used by this server to do the classification. And here's a look at that classification XML file. It's very simple, actually. It shows two applications defined with a URI pattern. The first one is /SuperSnoopWeb with a wildcard asterisk. That's going to catch the SuperSnoop URLs coming into the server. And the second one is URI of ATS_JDBC. That's for the JDBC application. And we see for Super Snoop, the transaction class Snoop will be passed into WLM. And for the JDBC application, the transaction class ATS_JDBC will be passed in. Now, if in the event a request comes in that doesn't hit either of those, then we'll take the default transaction class of Z9DEFLT as shown here. And that's it. That's the XML classification file that will be used in this scenario. Now let's take a look at the WLM classification rules that are in place for this environment. And if we come into WLM and we look under Classification Rules Option 6, and we just take a look inside the CB classification rules, we see, in this case, very simple set of definitions. The CN stands for collection name, and that is set at Z9*, which means that for our server, which is Z9SR01A, that would apply. And if it was just that, then it would pick up the service class CB class. But we have three TCs defined underneath that. One is TC default. That's the one we looked at in the XML file in case a URL comes in that's not Snoop and not the JDBC application. And then the next two are for Snoop and the JDBC application. TC Snoop, we saw Snoop defined as the transaction class in the XML file. And ATS_JDBC, we saw that value defined in the XML for the JDBC application. Now, if you look over to the right, you see that both Snoop and the JDBC application will get the service class CB class, the same service class, but the application will get a different reporting class. Snoop will get a reporting class of Snoop, and the JDBC application will get a reporting class of ATS JDBC. Here's a quick look at the address spaces for our WAS zOS environment. We saw this back in video 1. Here we're showing you that we're only using one servant region. The reason why we're doing that is we want to emphasize that this functionality is not dependent on multiple servant regions. What we're about to show you works perfectly well with one servant region or multiple servant regions. So in this demo, we're showing you with one servant region. So here's the environment that we'll use for the upcoming demonstration. We have our application server, and in our application server we have two applications deployed, Super Snoop and the JDBC application. We have a classification file designated for this server that was done with the environment variable that we saw. The WLM classification rules are in place that we just took a look at, and we're going to drive the requests into this server using the JMeter driver program, and we have it configured to drive 2 user threads for the Snoop application and 2 user threads for the JDBC application, and those thread groups are set to just loop and just keep driving and driving the applications over and over again. So let's go watch this in action. And here we have a 3270 screen set to SDSF enclave to show the enclaves that are being created by the work requests coming in. And in the foreground we have a telnet session which we'll use to start the JMeter program. So let's start JMeter, get those users driving work requests into our server, and we'll flip over to 3270 and we'll see the enclaves being created, and we'll see the reporting classes that are assigned to those. So there, JMeter is started. There is a couple of work requests coming in. We see the reporting classes. 2 of the threads are picking up ATS JDBC. 1 of them is picking up Snoop. In that case, I hit the enter. Now I've got 2 with Snoop and 1 with ATS JDBC. And there's 2 of each, and it just goes on and on. For every request that comes into this environment, the request gets classified with the XML file. The TC gets passed into WLM. WLM picks up the reporting class, passes that into the servant region. Here's proof that the reporting class is in play. And here we're showing the output from an RMF job that is extracting information by reporting class. Now again, pause and think about what we just ran. We had 2 applications running in the exact same server, but we had a classification file that was assigning different reporting classes to each. And with that in place, we are able to ask RMF to give us the usage and performance statistics by application, separated from one another. And here we're showing the ATS JDBC reporting class, and we see that 29,618 transactions were executed in the interval with a rate per second of 76.40. And this is from the same RMF job. Just scrolled down one page that's showing the reporting class information for the Snoop reporting class. And again, if we take a look down here, we see that 19,742 were run in the interval with an ending rate of 50.92 per second. So what we showed was 2 applications running in the same application server, but we didn't have to stop with 2. We could have gone to 3 or 5 or whatever the number is and done the exact same thing. Used a WLM classification file, uniquely identify the application requests coming in, assign those application requests to different reporting classes, and then use the tools to report on the system information specific to each application. The benefit of this: multiple applications in the same server is a reduced footprint for the application servers without loss of granularity of information. Before WAS zOS version 8, one of the objections to running multiple applications in the same server was that key settings would apply to all the applications in the server, such as timeouts. And the desire was to have those values apply to each application individually. Well, starting with version 8, that capability was provided by extending the XML classification file to allow application settings to be placed to individual applications. So let's see how this is done. Here's a snippet of the classification file that we used earlier, but notice that we've extended it with, in this case, a keyword dispatch timeout. And we're showing Super Snoop getting a value of 30 seconds, and we're showing JDBC getting a value of 300 seconds. Now that is an example of having different behavior set for each application within the same application server. But dispatch timeout are not the only keywords that we can use with this new function. Here is the list of the keyword settings that are applicable, and they roughly categorize around timeout values, dispatch progress monitor values, SMF recording values, tracing values, custom message tagging, and timeout recovery actions. Now for the upcoming demo, we're going to use the custom message tagging function because that's the easiest to show. But as we go through this, please keep in mind, this is the list of functions that you can use to get specific behavior to applications in an application server. So here's the classification XML with the message tag keyword added to both Snoop and the JDBC application. And here's the result as seen in the output for the server. The Super Snoop application is being written out with the custom tag of tag equals Snoop, and the JDBC application is coming out with a custom tag of tag equal JDBC. It's also possible to use a zOS modify command to introduce an updated or new copy of the classification XML. So here's an example of the modify being used, and let's go look at the effect. Before the zOS modify command was issued, the XML file was using a custom message tagging of tag equals Snoop and tag equal JDBC. The modify command introduced a new XML file that changed that custom tagging to tag equals Snoop2 and tag equal JDBC2. Here we see the result. The modify command brought in the new XML and the changes were applied dynamically. So in this demo we showed how message tag was used, but please keep in mind that all these other values are also available for your use, so that behavior of the application can be controlled at the application level and not just at the server level. If you're interested in more information on the Granular RAS function, we draw your attention to the WP102023 tech doc at ibm.com/support/techdocs. That has a wealth of information on the function and detailed information about every one of the keywords that we showed you earlier. And that's the end of this video demonstration in which we looked at WLM classification and how it's possible to get separate reporting classes to be used for applications within the same application server. And we looked at the Granular RAS function, which was a way to drive WebSphere behavior down to the application request level. And that's helpful when you have multiple applications in the same server, but they have a requirement to have different settings. There's more WAS zOS demonstrations in the other videos.